Now, just as we talked about some of the properties of logarithms when we talked about it, a bit back, now that we're dealing with e to the x, we should probably remind ourselves of some of those properties. Now, e to the x plus y is the same as e to the x times e to the y. Remember, when I multiply two exponential functions of the same base, I simply can write it as one base with the sum of the exponents. E to the x minus y is equal to e to the x over e to the y, which I could also write as 1 over e to the y minus x, which is e to the y minus x to the negative 1, which I'm going to come back to this in just a second, because this next property tells me if I have e to the x raised to the y, that's the same as e to the x times y. So here I have e to the y minus x raised to the negative 1. So I can multiply this by negative 1, which is e to the negative 1 times y minus x, which is e to the x minus y. I only did that because I just wanted to go full circle to show you that all these really are equivalent to each other. Now, ln e to the x is equal to, based on the property of logs, we've already looked at this idea, it's going to be x times ln e, but as I said earlier, ln e is 1, so this is actually just the same as x. And e raised to ln x is also simply equal to x. Now, this one is sometimes a little bit confusing, so let's just talk about just for a second. I mean, I know this is an algebra review, but it might be a good thing to do. Let's just think about ln x for a second. Ln x, that's the same as log base e of x equals some number k. These are saying the exact same thing. Well, this can happen if and only if e to the k is equal to x. That's just the definition of logs. Now remember, ln x then is the same as k, and e to the k equals x. Well, if k is ln x, e to the k equals x, then e to the ln x, remember that's k, equals x. So you may want to walk back through that a couple times and make sure it makes sense to you. But just by basically the definition of logs, that's how we get to this statement.